Welcome to provisioning volumes and allocating those volumes to hosts over NVMe-over-Fabric to the Pavilion HyperOS storage array, part of the Pavilion video series. I am Kostas Apopoulos, the Chief Field Technology Officer for Pavilion Data. I'll be joined by Phil Aronowitz, one of our Senior Principal Solutions Architect, who will actually be delivering the demonstration. So in today's video, we're going to do a few things. First, we're going to start with a comparison of how you provision using the Fibre Channel way versus this newer modern way of NVMe-over-Fabric. We're going to give you an overview of the Pavilion architecture and how it applies to this process. And then as part of the actual demonstration, we're going to create the volumes on the Pavilion hyperparallel storage array. Then we're going to focus on Linux hosts, assigning those volumes to a Linux host leveraging NVMe-TCP protocol. Do that same thing and then leveraging the NVMe-over-Fabric RoCE protocol or the RDMA protocol. We'll then switch gears and go into Windows and assign a Windows host using NVMe-TCP, and then do that same thing doing NVMe-over-Fabric RoCE. We get asked quite a bit, what is the difference between configuring and provisioning a volume on Fibre Channel versus a new, more modern way, NVMe-over-Fabric? So really, how is that different? Let's start with the Fibre Channel provisioning process, or the Fibre Channel way. You create a volume on a storage array, you assign that volume to a controller, you mask that volume to an HBA, then you create zones for each initiator target pair, then you go to the host and you discover that volume, and then of course, then you create a file system. Well, in the new way of NVMe-over-Fabric, it's very similar, but a little simpler. You create that volume on a storage array, you assign that volume to the controller, then you go to the host and you discover that volume on the host, and of course, then you create a file system. So the process is incredibly similar, but actually a bit easier and a couple less steps. So before we actually get into the demonstration, let's look how we do these steps on the Pavilion multi-controller architecture hyperparallel array. So the first step is we create a volume. We create that volume on any one of the media groups in the Pavilion storage array. We then go to any one of the controllers and we assign that volume to one of the controllers and define that controller as a protocol. We then go to either a Linux or a Windows host, and we can map that Linux host to that controller leveraging NVMe-TCP or NVMe-RoCE. Of course, there are other protocols that can be leveraged in the Pavilion array for block like iSCSI or NVMe-RDMA, the InfiniBand technology. This demonstration is just going to happen to show you the process using NVMe-TCP and RoCE. The other two are actually the same. So with our multi-controller architecture, we give the flexibility to do NVMe-over-Fabric TCP or RDMA, or as I said, other protocols, the flexibility to leverage one or many controllers and assign that to the host. And by doing and leveraging that scale-out architecture of Pavilion, we get linear performance. As we add controllers to a host and volumes to a host, we get linear performance. So with that, let's move over to the demonstration. Back to you, Phil.
First, we start off by navigating to the URL of our Pavilion hyperparallel flash array. I'm going to log on using our local admin credentials. We're going to be creating 3 volumes for discovery on Linux and Windows operating systems via TCP and RDMA protocols. So we start by navigating to our block store. And to create a volume, we simply click on Create. Here we're given the option to provision one or multiple devices based on the capacity that we're selecting. First, we're going to select our media group. I'll choose media group 2. I'm only creating one volume for the sake of this demo, and we're going to call the first one Linux V1 for Linux Volume 1. We're going to specify that it's 500 gigabytes in size, and we'll put a 100% reservation on it for optimal performance. We also want to check off Discover Storage Entity by Name. That gives our host administrators the ability to discover the device by the name that we've assigned it, Linux V1, as opposed to using a long NQN. Then we're going to go ahead and click OK. It's almost instantaneous. The next task that we need to do is selecting that device, and we're going to assign it to a controller. Here we'll just select controller 11 in Media Group 2. While we're waiting for that assignment to happen, we're going to go ahead and create the 2 volumes for Windows. We'll also create them in Media Group 2. We will call the first one Windows RDMA. Again, we'll create it 500 gigabytes in size, and we'll be able to discover it via its simple name. We'll go ahead and select that device, assign it to controller 12, and finally we'll create the 3rd device that we're going to be using on our Windows RDMA, our Windows TCP host. Again, I'll select Media Group 2. We're creating 1 volume. We're going to call it Windows TCP. Create volume 500 gigabytes and select Discover Storage Entity by name. Next, we'll check that one off. Assign it to controller 13. And it's as simple as that. In the next video, I'll show you how to discover and create file systems on those devices. Thank you. We'll be discovering the device we just created for our Linux host, Linux v1. There's 2 pieces of information that we need. First, we need the IP address of the controller the device is mapped to, which is 192.168.2.11, and we need the name of the device, which is Linux v1. It is case sensitive. So let's go over to the server. To discover the device is as simple as issuing NVMe discover -T in the protocol. We'll be using RDMA first, and the IP address of the controller. And here we see it's discovered the controller and the devices associated with that controller. And next we're going to connect to it by specifying the name of the device. Now, if we go in and look at our discovered NVMe devices, we have discovered device NVMe-0. Create a file system on it. And then we're going to go ahead and mount it. We'll create a mount point for it. And now we can view the file system that we just created, which is on device /dev/NVMe0N1. We see the size is 467 gigabytes, and it's mounted to /MNT/NVMe0N1. Thank you. Next, we'll be discovering the same device, Linux v1, via the NVMe-TCP protocol on our Linux host. Again, we'll need the name of the device, which is Linux v1, and the IP address of the controller it's attached to, which is 192.168.2.11. So here we'll issue the NVMe discover command. And unlike last time, we'll be using TCP as opposed to RDMA as the protocol. We have to specify the port, which is 4420. As well as the IP address of the controller, which is 192.168.2.11. Here we see we've discovered the controller and the Linux v1 device, so let's now connect to it. We have successfully connected to the device. NVMe0N1. Let's go ahead and make a file system on the device. And then we're going to go ahead and mount it. Mount. First we'll make a directory to mount it to. NVMe-0N1. Now we're going to simply mount it to that directory. Now if we go ahead and view, we see we have our NVMe-TCP device mounted to /MNT/NVMe-0N1. And again, the size is 467 gigabytes. Thank you. Next, we're going to discover volume via Windows RDMA on a host that has the StarWinds RDMA and NVMe driver installed. Again, we'll need the same information that we needed for the Linux host, which is the name of the volume, Windows_RDMA, and the IP address of the controller, which is 192.168.2.12. So we navigate via command line to the directory the StarWinds driver is installed in. And first we're going to initiate a discovery where we're going to enter in the IP address of the controller, which is 192.168.2.12, and the port, which is 4420. And we have to enter in the localhost IP address as well, which is 192.168.2.111. Now here we see that we've discovered that that volume has, that controller has two volumes associated with it, and we'll be discovering this volume. So now we'll enter the insert command with the target IP address, which is 192.168.2.12, and the port 4420. Our local IP address, which is 192.168.2.111. And now we have to enter in the device name, which is Windows_RDMA. And then we're going to enter in the local host name. It could be anything you want. We'll call it the same thing, Windows_RDMA. We see it's completed, and if we look over in Disk Manager, we see we have a newly discovered 500 gigabyte device, which you can initialize and create a file system on. Finally, we'll be discovering our Windows TCP device via the Pavilion Windows TCP driver. Again, we'll need the name of the volume, which is Windows TCP. And we'll need the IP address of the controller it's attached to, which is 192.168.2.13. We'll head on over to our Windows host and launch our Pavilion NVMe-over-Fabric manager. First, we'll go over to Discover, and we'll simply enter the IP address of our controller. It's 192.168.2.13. Simply click Discover, and it'll show the devices that are associated with that controller. We'll go ahead and check off the Windows TCP volume, click on Connect and Save, and now we see the newly discovered 500 gigabyte NVMe-over-Fabric TCP attached device. Thank you.
Thank you for spending time today to learn about how to provision volumes on the Pavilion hyperparallel storage array. If you want to learn more, check out our other videos at www.pavilion.io or reach out to us via email at info@pavilion.io, or always reach out to us on the phone. We'd love to talk to you about how we can solve some of your most challenging storage-related IT problems that we can help you deliver better outcomes to your business. Thank you.